All right, welcome to the second part of coding 10 LeetCode questions under 60 minutes, 10 easy LeetCode questions. So before we start, I think I should change the appearance to dark so that it's easier for the eyes, right? And then, yeah, so we just do easy and then algorithm questions and then sort by the acceptance, right? Okay, so okay, I guess this one changed, moved up a bit. So I guess we can start from here. Okay. So I think it's all good. And then let's start the timer. Okay. So it says you're given integer array nums in one operation. You can add or subtract one of any of the elements of nums. Return the minimum number of operations and make all the elements nums divisible by 3. Okay. Given integer array in one operation, you can add or subtract one from any element. Okay. Return the minimum number of operations. Make all the elements. Okay. So it's all the elements. I thought it was like combining something or like that. Okay. So I think in order to do this, we can just analyze one number at a time, right? And if the number is like 1, I think it's easier to subtract because subtracting 1 is just going to be divisible by 0. And then if it's 2, then we just add 1, right? So it's like we can get the remainder of each number. And then if its remainder is 2, then we just add it. And then if it's 1, then we just subtract it, right? So that's the idea. So basically, I guess the algorithm is pretty simple then. If it's divisible by 3, then we just don't do anything, right? So we just 0. There's no operation we should do. But in any other case, we just increase the count by 1 in this case, So in this example, we only have 3 as a divisible by 3. And then on the rest, we just add, 3 times, basically. Okay, so let's go on to the code. It's like nums, and then count is like that, and then if n is divisible by 3, count plus, sorry, not divisible by 0, count plus 1, and then just like that. Okay, I hope you guys understood the algorithm. So basically, like, if it's divisible by 3, then it's obviously 0, right? We shouldn't be doing anything, but in any other case, we can just add 1, like the here, and then subtract 1 in here. So that's why it's like this. So let's just try that. Yeah, I think this works. Okay, let's just submit it. All right, that's good. Okay, that's the first problem. And the next problem is you are given 2 positive integers n and m. Define 2 integers num1 and num2 as follows. The sum of all integers in range 1 and n are not divisible by m. Sum of all the integers in the range 1 and n that are divisible by m. Return num1 minus num2. Okay, I guess I didn't quite get it. Let's just look into the example. So n is 10, m is 3, the output is 19. Give me an example. Okay, so in 1 to n, 1 to 10, they're not divisible by 3. Okay, so these are the numbers that are not divisible by 3. And num1 is the sum of those integers. Okay, so we just add everything. That's num1. And then integers in range that are divisible by 3 is here. Num2 is the sum of all the integers. Okay, we just return the answer. Okay. I guess we could just basically brute force this, and I'm sure it's gonna be, it's gonna give us the answer. But is there like a really good way of doing this? Not sure. 1 to n 3. I guess there is a good way of doing this, like optimal way. So let me think. 1 to 10, 3. So what I'm thinking is, obviously, I can just do it brute force. Okay, let's just do the brute force, and then we can do the optimal solution later. And then let's just do like s equals 0, and then for I in range of 1 to n plus 1, because we don't want, we want the n to be included, right? So if I divisible by m is equal to 0, then we subtract the I. And then if it's not, then we add the I. And then I think I could just return the S. Okay, yeah, this works definitely. Okay, so this is like the brute force solution, which, oh, I guess I forgot to put the time complexity and space complexity in here. Okay, so this is time complexity is O of n, and space is O of 1 in here. In here, this solution is definitely, let's just do here. Time complexity is O of n, and space complexity is O of 1. So there's no like additional variable that we're doing. Okay, so that's the first brute force solution basically. And then the next solution that I'm thinking of is there is an equation that we can use. So for example, like 1 2 plus 1 plus 2 plus 3 plus blah blah blah, like n is equal to n times n plus 1 divided by 2. So that's the equation, right? So this is like an arithmetic progression. And then we can divide the n by this. Okay, so wait, let me think. So basically, this is the sum. And then we need to subtract like 1 plus m plus 2m plus 3m. And then, goes on until n, right? So we need to subtract this like 2 times, not just 1. Because just subtracting 1 time would just give us here. But we also have to subtract it again, right? So that's the idea. Oh wait, sorry, this is not supposed to be 1, so it should just start from m. Okay, so let's just do like it goes until k, right? Okay, so we have k times here, and then if we do some mathematics like algebra, then we just get m outside the parentheses, and then this becomes 1 2 plus 2 da 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 plus k. So which means we can use this equation again, right? So m times k plus 1 divided by 2. Right, so this is the sum. Okay, so what's k then, right? So k is basically n divided by m, like the floor division, right? So in this case, the k is basically 3, right? In 10 and 3 case. So that's that. So we'll just use this equation, and then I think we can do it. Okay, and then, okay, so let's just do it Sn. Sn is exactly this, which is 1. I'll just do a comment in here. Okay, so this is the Sn. That's the sum. And then we'll do this one here. And then call it like Sm, I guess. And that's okay, so let's find k first. So k is like that. So k is that. And then Sm would be m times k. It's just basically this, so let's just copy it. Okay. And then the answer would be Sn minus 2 times Sm. So essentially we can, get rid of the divided by 2 in here, and then immediately subtract here, basically. Okay, I think that should do it. Let's just get rid of this one, then see if it works. Oh, okay, what is it called? Oh yeah, there's supposed to be a multiplication here. Okay, yeah, it works. So let's just do submit. Okay, it's it's pretty fast, I would say. Let's do the complexity analysis, right? So the complexity analysis would be time is just 1 because we're just doing multiplication and addition, right? And then the space is also 1. So this is like the most optimal solution. Okay, let's just submit it again and see if the millisecond changes. It's around there. Oh well. Okay, that's that. On to the next problem then. Okay, jewels and stones. Okay, I think I've seen this before, definitely. So it says you're given string jewels representing the type of stone that are jewels, and stones representing the stones you have. Each character in the stones is the type of stone you have. You want to know how many stones are also jewels. Okay, so if you don't understand it, I think it's easier to just look at the example. So basically, you have a bunch of like stones, right? But you don't know if those are like jewels or not. But you also have like jewels string, which represents, okay, these strings, like these characters are jewels. So lowercase a is a jewel, uppercase a is a jewel. So from here, which one of how many jewels are there, right? So that's the question. So this is like lowercase a is a jewel, and this is a jewel, and this is a jewel. So we have 3 jewels in here. So that's why it's 3. In here, there's no jewels, right? So lowercase z is the jewel, and these are not these are just regular stones. There are no jewels here, so that's why it's 0. Okay, so I think it's just easier to just do for loop on the stones, and then check if the stone is jeweled or not. I think that's gonna be like nested loop, and then the time complexity would be just squared, right? Like n squared. But that's not the optimal solution. The optimal solution would be to use a set. So we just turn the jewels into a set, and then that makes it easier for us to check. So let's just do like J set, right? And then J set would be just set of jewels. So we turn the string into jewels. That's good. And then we go to S and loop through the stones and see if this S is in the J set, which is a jewel, right? And then if it is, then we just increase the count. And then just return the count. So that would be the optimal solution. So in here, the time complexity would be O of n, and the space complexity would be O of m, I guess. So n is number of stones, and m is number of jewels. Okay, so that's the time and space complexity. So let's just check if this works. Okay, it's working. Let's just submit it. Okay, there we go. It's working. All right, let's do the next one. Shuffle the array. Okay. What's it saying? Given the array of nums consisting of 2n elements in the form of, okay, so it's just like that. And then we want to do array of like that, okay. So we just put this here, and then this one over here. Oh wait, is it not like that? Oh, okay, okay. X2 is, and the next one, Y is the next one, stuff like that then. Okay. I guess the easiest approach of here would be just to like create like a new list and then pick the elements, and that would just give the answer. I think that's going to be like the brute force approach. I'm sure there's an optimal solution to this. Like there's no need to use extra space, because creating a new array would create extra space, right? How would that work? So if we swap this one, then x2 becomes here, but x2 should be over here, and y2 should be over here. Then yeah, it becomes really, really hard. But let's just do the brute force solution first and see if that is working well. So yeah, I guess I can just do like 2 times n, so like create an array that is 2 times the length. Or just I can just do like instead of this, I can just do like length of nums. The length is the same, right? Like that. And then for I in range of, I think we can just do until n. And then R of I is equal to, okay, so we have, I think it's 2 times I. Okay, so we can use, right? So we have x's in the odd spaces, I guess. So here, here, and then also in here, right? That would be the x's. So the first one would be the x, so which is nums of I. So those are the x's. And then now we have to do the y's, which is 2 times I plus 1. Then the y's would be I plus n. Okay, so that would be the solution, I think. Okay, that's good. All right. Yeah, I'm not sure how to even do the optimal solution. I'm not sure if there is one, but there might be one. I just can't tell. The time complexity is O of n, and the space complexity is also O of n. I guess we can just lowercase n because we have the lowercase n here, right? Okay, let's just leave it at this, and then I'm not sure if there is an optimal solution. Maybe we can check the submissions over, no, what is it called? The solutions, and then maybe there is one, but I'm not sure. We can get back to this later. But let's just keep going until then. Okay, shuffle the array. Find words containing character. Okay, let's do this. Okay, you're given 0 index array string words and the character x. Return the array of indices representing the word that contains the character x. The returned array may be in any order. Okay. So I guess it's pretty simple then. Okay, so basically we have list of words and then given a character, and then just check if these characters are within the strings, and then keep track of the indices and store the indices and return them then. Okay, I think this is pretty simple. So there's no gotcha in here. I don't think. There's just looping through and then checking the strings and stuff like that. So let's just create like empty array and then keep on adding the indices, right? So for IW, let's just do word and enumerate words. So enumerate, it makes it easier for looping index and the item, right? So that's really convenient here actually. Okay, and then if so in Python you can actually do this x in word. So this means if the character is inside the string, so we can do that in Python. And if it is, then r dot append I, and if it's not, then we just don't do anything, right? So that's the algorithm. Okay, that's good. And the time and space complexity would be, I think of n times m, where n is the number of words and m is the average length of word. Okay, because like this if statement is also checking, it's looping one by one, right? And then checking if the character is within the word. And then the space complexity is, we were creating a new array and then adding it, right? So, and then the array can be as large as the number of words. So basically it's O of n. Okay, so that's the algorithm. Did I do submit? Okay, I guess I didn't do submit. Okay, there you go. Yeah, and then obviously there's just no way that there's an optimal solution than this, because the words are random, and then there's no optimal like way of checking character within the string, like instead of looping, right? So this is just what it is. All right. Find words. Okay, character largest local values in matrix. Okay, what is it saying? Largest local values in a matrix. You are given n by n integer matrix, great. Generate an integer matrix max local size of n minus 2 n minus 2 such that okay, basically it's like the local maxima of inner matrices then. Okay, so the idea is that you have this 4x4 matrix, right? So this is an example, and then what's the maximum number of these 4, right? So it's 9, so we just put 9 here. And then what's the Oh wait, it's not that, I guess. Oh, is it not overlapping then? Let me see. Oh, it's far largest of the 3 by 3. Okay, sorry, I mistaken. Okay, so that's why. So we have this 3 by 3, and then the largest value of these 3 by 3 is obviously 9. And then largest of these 3 by 3 is also 9, so that. The largest of these 3 by 3 is 8, so that. The largest of these 3 by 3 is 6, so that's why we have these, 2 by 2 as the answer. Return the generated matrix, okay. All right. I'm just wondering if there is like an optimal way to do this. I'm just trying to, compare like 9 by 9. Sorry, not 9 by 9. 3 by 3 squares all the time, and then we just return the largest, right? So that's my initial thought. That's obviously like brute forcing it, but I'm not even sure if there is a optimal solution. Maybe there is, maybe there's not. Let me think. So we have 9. Yeah, I don't think there is much optimal solution. Let's just do like brute force solution and then see how it goes. I'm sure there is. The LeetCode will accept that for sure. Okay. So let's just do this. So on these like two-dimensional problems, I really like to create like variable where you have row, right? Row is the number of rows, which is the length of grid. And then column is the number of columns, which is the length of the first one, right? And then what I like to do is a for I in range row, and then for j in range col. So this is like the way of doing, way of iterating through every cell in the matrix, right? But we don't want every cell in the matrix. We want -2, right? Because we don't. So that's like we are going to be analyzing from the top left corner, and then here, and then here, and then here, and then the rest will be like 3 by 3. So that's why we don't want to go over. So that's gonna create like index out of bound exception. So we're just gonna go until -2, and then we can just create like response, and then what should I do? Response row, I guess. So on each analyzed row, we have to create a response row, and then at the end, basically we add that response row into the response. So basically like that, response append response row, and then in here, I can create like a helper function, or I mean, I don't have to create a helper function, but basically like the max number is equal to get max. I guess I can do that. IJ. So that's like the starting index, and then it will give me like, okay, what's the largest number starting at this index, right, top left index, and then return the maximum number. And then if it returns, I'll be adding. I guess we just don't have to create a variable. We can just instantly add it here, like that. So on each row, we append the maximum, and then after that row is done, we append it to the result, and then finally we return the result, or response, I guess. Okay. So so we have to create this function here. So in Python, I guess you can create a function in here, right, like this. But since we want to use the grid variable, we can just create like a local function like here. Yeah. So in Python, you can do this. Then you have I and j. That's the starting index. Oops. And then just return like 3 by 3 3 by 3 grids numbers, right? So what you do is a max num is, let's just call it the ij. Let's assume this is the max, right? And then if it's not the max, then we keep updating it. So for how should I do this? Let's just do, maybe this, I should call this x and y, and then my in range x plus 2, or j in range y plus 2. So we're gonna loop through the 9 numbers, and then max num would be the maximum of the grids I, j, oops, here, or the maximum number itself, right? So that will give us the maximum number. And then I would also have to update here. Okay, so this gives me the local maximum of 3x3 grid, this function, and then we're just gonna use that function every time in here. So this is basically the brute force solution, and I'm not really sure if there is an optimal solution than this. Let's just test it and see if it works. Oh, there has been error. Max num grid xy. IJ. Okay, so what's wrong here? So the first test case is good, but the second one is not. What's happening here? Okay, yeah, I guess it should be all the 2s, but we have a bunch of 1s and then 1 in here. Okay. So range row -1, row -2, call -2. 1, 2, 4. Yeah, that is correct. Okay, yeah, -2s are correct. And then, so the get max function is definitely returning something wrong. So, which means in here, x plus 2, y plus, oh, this is not ing. Damn, it's, oh wait, it is. Yeah, it is, because we have ing in here. Okay, x. Okay, so x is the I, which is the row, and then row call max num. Yeah, this is super weird. I'm not sure what is happening. Maximum of the grid, max num. Yeah, I'm pretty sure the get max is doing something wrong. Maybe there's like a variable conflict or something. Let me just do like JJ, J, but I'm sure this is not gonna change anything. Yeah. Y, J. Okay, let's just print I and J in here. I like to print it as a tuple so that it's really easier to see it. So it's, yeah, this is all good. Oh, wait, it didn't. Oh, no, I think this is correct, right? 2, 0 on every 1, 2, 3, 1, 2, 3. Oh, view more, definitely. Okay, yeah. I was thinking like there's missing one. Okay, then 2, 2. Yeah, this is okay. This is the I and J are correct. And then in here, x and y, max number is yeah, it's the same thing. Why? I'm sure some of you just caught the mistake and screaming at the screen, but for me, I'm not sure what it is. Grid. I didn't change the grid. Maximum of grid. IIJJ. Let's just do like 0 in here so that we can distinguish each call. Oh, wait, what? This is only checking. Oh, it's +3. It's only checking 4 elements. Okay, not checking 9 elements. That's why. It's an obvious mistake. I spent too much time fixing this. Okay, yeah, now it's good. All right, let's just submit this. Okay, so 143. Okay, so this is telling me that there is an optimal solution to do, which I'm not sure though. I will have to think about it more. But if you have time, I will just try to think about it. But let's just move on, and this is solved. But yeah, I'm sure this is like 40% faster than this current solution. So I'm thinking there is an optimal solution then. Yeah, I just have to think about it more. Yeah. Okay, so 6 problems, largest local values matrix, richest customer wealth. Okay, let's just open the next 4. Okay. Richest customer wealth. Okay. You are given an n by n integer grid accounts where account I is the amount of money of the ith customer has in the jth bank. Okay, and then return the wealth that richest customer has. Okay. Both customer considerations and best of return 6. Okay, so basically just add all the rows and then return the maximum then. Okay. Yeah, okay, I see. So basically the idea is we add every row and then there's going to be a number, right? And then we just compare those numbers and return the maximum. So that's going to be the wealthiest person. I think we can do like richest as in accounts of 0, and then we could just do a summation, right? So let's just assume the first row is the richest one, right? And then after that we can check if the richest one is not the case or not, and then we can go on from there. Okay, so since we already checked the first one, we start from the next one, and then richest would be maximum of sum of accounts of I, and then richest. Return richest. I just clicked submit. I'm pretty sure it's gonna work out though. Okay, yeah, it's working. Okay, and obviously there's not gonna be an optimal solution more than this because every number is gonna be random, right? And then there's just no way of predicting which one is gonna be the richest. So we're doing the optimal solution in here where, oh yeah, I forgot to do the time complexity in the previous one. I have to do that. Time complexity would be of m times n, which, you know, m is the row and n is the column, basically. So we're doing summation on every step and then comparing it, right? And then, but the space complexity is actually nothing. So we just have O1. We didn't create any new variables. So this is going to be the optimal solution. Okay. And then let's do this next one, which, okay, this is going to be kind of like a design problem then. So how many minutes we have? Okay, we have 27 minutes. That's good. Design a parking system for a parking lot. The parking lot has 3 kinds of parking spaces, big, medium, and small, with a fixed number of slots for each size. Wait, what? Okay. Okay, with parking system, we assign the number of big, medium, small numbers initially to object parking system. Number of slots of each parking space not given the part of the constructor. Yeah, okay. Add car checks whether the parking system has space. Okay, I see. So we just keep adding cars then. Can be big, medium, or small makes sense. And then which, okay, so big is 1, medium is 2, and small is 3. Okay. A car can only park in the parking space it fits car type. If there is no space available, return false. Else park the car in that size, return true. Okay. I wonder if we can add small car into a big space. I'm not sure. Let's just look at the example. Maybe there is in the description, but let me see the example first. Okay, so we have 1 big space, 1 medium space, and 0 small spaces. And then we are adding 1 big, okay, which fills up that. And then we are trying to add 1 medium, which fills that. Small, there's no space. Big, there's no space. Okay, this is fully occupied. Okay. But let me see. Checks whether so it didn't answer my question, right? If I can add small car to the big space, it can be 3 times. Which person 1, 2, 3? Car can only park in the parking space of its car type. I guess it doesn't do that. Okay, that makes it easier. Right. So since then this is like a class problem, we have to create like a class variables, right? So we self.big is equal big, self.medium is equal to medium. Somehow we have to store these variables, right? So okay, so those are going to be the first step. And then what else? So what I'm thinking is just keep on subtracting if there is a car type, and then we just check the car type, right? Okay. So for example, if car type is equal 1, and then we just subtract from big, right? But there's also a case of if self.big is equal to 0 already, then we return false. Then else we return true. But we have to subtract it first, right? So we just basically copy this 3 times. Okay, car times 2, and this is medium. I guess to make it cleaner, I think I can just create like an array. I think that makes it much cleaner. What should I say? Sizes? Not sizes. It's like capacity. Let's just say capacity. Big, medium, small. So these are the capacities I just turned into array instead of declaring 3 variables. I think this is much cleaner. Okay, so if the car type is 1, I don't even think we need this, to be honest, because what I can do is if self.capacity of car type -1. So this gives me the appropriate index, right? So if it's 1, then it's 0, which is the big car's capacity. And then if that is, greater than 0, and which means it's available, right? Then we do self.capacity car type subtract 1 and then return true. Otherwise, we just return false because, the capacity is 0, which means we can't fit it. I think this just should work because this, works on all. Oh yeah, to subtract 1. This works on every car type, which is far better than the last solution. Okay, so I forgot the character. Yeah, it's much cleaner. Okay, let's submit this and see how it works. Okay, yeah, it worked. Nice. So there is no like optimal solution than this. This is like pretty much the optimal as it gets. So the add car function is just 1, and then the initializing function is also 1. This complexity is also 1 because we're storing only 3 variables, which is not scalable, right? It's not scaling upwards. So space and time complexity is just both 1 for all of these functions. Like in initializing, we have this. Adding car, we have this on both of these functions. All right, so let's go on to the next. Oh yeah, I think we can just go on to the later on. I forgot to do the complexity analysis of the matrix problem before. The XOR total of an array is defined as bitwise XOR of all of its elements, or 0 if the array is empty. For example, XOR total of the array is XOR 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 1. Given an array nums, return all the sum of the XOR for every subset of nums. Wait, what? Subset are the 4 subsets are empty, 0, okay, and then 1, 1, 3, 3, 6, okay. Okay, so this is asking like find every subset of the array and then XORing all the elements. guess there is some sort of trick to it, because I can't imagine we are going to be finding all the subsets, to be honest. Maybe we should. I'm not sure. Okay, let's move on to this problem, but let's just try to do this problem because this is super easy. Let's just go on with it and then focus on the most difficult problem. Return, I'm pretty sure this is just add two integers, right? Yeah, I give 2 integers to sum of the 2 integers. Okay. This is the easiest problem in LeetCode probably. Okay, and then the time and space complexity would be just O of 1. And space would be O of 1. Okay, let's just submit the code. Okay, so yeah, that's good. So did we do all 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, we have 10 problems. But let's do the, okay, I guess we can move on to here later. Let's try to focus on this problem. The XOR total of an array is defined as bitwise XOR of all of its elements, or 0 if it's an empty array. Okay, yeah. I'm trying to see if there is a pattern actually. XOR. So with one element, it's obviously just itself. So we have that. And then for all the elements, we have 2. Okay, let's move on to this example. So for 2 elements, we have that. For 3 elements, we have 2. I'm not really that good with bitwise operation and what it's meaning and stuff, but I'm really hesitant to see if this has actually like easy problem. Seems to me really hard. I mean, maybe there is a trick to it that I'm not seeing, but I mean, I can definitely solve this problem, but I don't think I will be doing it as the optimal solution though. Because, okay, let me see, XOR. So if you XOR into itself, let me just test something real quick. Print 5. Okay, so in Python, I think XOR is this caret symbol. Okay, it's just 0. So if yours XOR to itself, it's 0. Yeah, it's expected. And that is correct, right? Let me just quickly Google it real quick. Python XOR. Yeah, it's the caret symbol, right? Okay, it's caret symbol for sure. Yeah, let's just move on. Okay. But it says it's adding though. Then my suspicion is totally wrong. So adding all that. Okay, I guess I'll just solve it as brute force method and then see if that, gives me the, not time limit exceeded, blah, blah, blah. So since we're doing all the combinations, then all the combination count is like 2 to the n power, right? So we have, if there is like 2 numbers, then there are like 2 to the power of 2 is like 4. So we have 4 number of subsets. In here, if it's 3, then we have 8 number of subsets, right? So obviously the complexity is going to be something to the power of n. So that's expected. So which means what I like to do in that case is do something like, okay, S is the sum for I in range as, so we know the it's going to be like 2 to the power of n. It's going to be the size, right? So 2 to the power of nums, length of nums. So this is going to be the number. But the trick is that what I'm trying to do is creating a bunch of like binary strings for all these numbers. So if we print out the numbers, obviously it's going to be just 0 to something, 0 to 3, right? But what I'm trying to do is like convert these into binary strings. And then depending on like a 0 or 1, we were selecting that number from the list, right? So, okay, let me just try to do that. And I think I can do bin is the binary representation. Let me see. Okay, yeah, bin. And I think I should prefix these too. So if I do like 1 0 1 2, that, so this is like string manipulation, right? So this is just gonna be like give me the binary strings, but I have to append these. Okay, so let's just call this B, and then at the actual binary string should be 0 times. So I have to append like 0 in front. So let's just go to the case 2. I think this is much easier. Okay, so here this should be like 0 0 0, not just 0. So I need to get full like 3 length binary strings. So what I can do is 0 times length of B. Am I not? Okay, yeah, I think this is correct. Okay, yeah. Minus length of nums minus that plus B. Okay, oh wait, to print the binary string. Binary string. Ah, too soon. What? Okay, so if you have LeetCode Premium, I don't think I would get that problem. But for free versions, yeah. Okay, yeah. So now we finally have like the full length 0 1 0 0 1, right? Okay. So now we have that. That's good. And then what we do is go through each character of the binary string, and then if C is equal to 1, then we are using that number, right? Essentially. And then we use like XOR of 0, I guess. And then what I do is XOR of that. Oh, I guess I need the string. Well, not the string, the index to get the index. And then nums of I. I think that's good. Oh yeah, this is like string, not number. Okay, and then if we do that, then I can add it to the XOR and then return the S. Okay, so I think this should work. Let me see. Okay, yeah, this works. Let's see if this gets accepted. I'm sure it's gonna get accepted. If it's not, then I don't know. I mean, I'm not sure how to do it. Okay, yeah, mine is pretty slow. Okay, so my time complexity is pretty slow because time complexity is going to be 2 to the power of n times the length of that binary string, right? So it's like length of n, I think. So n times, let's just do this, n times 2 to the power of n is the complexity. So this is 2n, and then this is just n, and then this is going to be looping through each character of that string. So okay, I think this is good. Yeah, 2 to the power of n. And then the space complexity is I think it's just O of n. N is the length of the list, right? So because like we're creating like binary string stuff in here like that. Okay, so this is making me think that there is an optimal solution in here because there's like a huge bump in here, right? But I'm not sure what that is. Maybe I can see it from the solutions, but yeah, I'm not sure if there is an optimal solution to, oh no, sorry. I'm not sure if I can come up with the optimal solution better than this. I think this is as good as I can get. But yeah, let's just refresh the code and see if this is actually like 10 problems that I did. Okay, so with which problem did I start? I find minimum. I guess that's a bad way of doing it. let's just count, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, that 19 is good. Because on the last video, I did the problem that was on top, which, it was not supposed to happen. I shouldn't have just skipped this part because this was the daily problem. Okay, I think I did all 10 and then, I spared some like 10 minutes or so, but I think I should write the time complexity in here. Okay, so the largest local in here, the time complexity is just O of n times m. And then space complexity is is there anything that I did? Okay. Oh yeah, I guess the response, right? So the response is also gonna be n times m because when the matrix is larger than -3, I mean the -3 size, like this side doesn't matter, right? So the space complexity is also that because I'm creating new response result and then appending to it like that. And this function is actually just O of 1 because we're looping through just 9 numbers constantly, right? So that's why we don't have anything else. So that's the time complexity. And I'm wondering if there is optimal solution on that. We can just stop it, and then basically this challenge is done, and it's getting harder and harder for me because for this problem and for this problem, I'm not sure how to come up with the optimal solution. Okay, let's start with this then. Is there optimal solution than what I have here? Let's think. I was thinking of something like maximum heap, but then again, if I know the maximum of this is 9, then if I come up here, I have to subtract these 3 numbers and add these 3 numbers, right? So that in a way it just defeats the whole purpose because like for maximum heap, like subtracting these 3 numbers is not an easy task. You have to heapify the same. I mean, I don't think you can even do it because that in itself, the heap is gone basically. So that's terrible. But if there is no maximum heap, then let me see. Yeah, I don't know. I mean, I'm not sure if I can come up with the optimal solution. Maybe there is some optimal solution that is on the solutions tab. But this is also interesting. This problem, it's an easy problem, but yeah, I'm not sure if my solution. Okay, so in here, I think the optimal solution might be just using recursive backtracking to generate these subsets and then just XORing it. That might be like give some improvements, but I'm not sure if that's gonna matter. But I'm just afraid that there might be some trick, right? So there might be just some equation that calculates this already. I think there might be some trick that involves that. So is there a better way to iterate through the subsets of the array? Can we use recursion to efficiently iterate through the subsets? Okay, I don't know. I don't think these hints give me anything. Is there a better way to iterate through all the subsets of the array? Yeah, that doesn't give me anything. Okay, this question. Yeah, this is really an easy level question. Yeah, that's a good question. I am you day. It requires strong foundation recursion and backtrack. It is definitely not an easy problem. Okay, yeah, I agree with you. Holy crap, it's not an easy question. Okay, yeah, I agree with you. Yeah, sometimes LeetCode is like this. Yeah, that's why I am getting struggling. Yeah. Yeah, why is this an easy section? Yeah, I agree. I hate bit manipulation. I mean, I also agree. Okay, so what is it saying? So maybe this is the trick. Bitwise XOR of subsets array can be solved by performing bitwise or for every element in the final answer multiplied by like -1. Okay, maybe this is the trick. Okay. I did not find the solution by myself with the same method proposed in 2021. Okay, what? Let's choose math answer. Yeah. So basically what I'm trying to say is like, I really hate these types of questions because there is a trick, and then there's just no way that you can come up with it on the spot during the interview, right? Not except that you know the answer beforehand. There's just no way. So if I was given to this interview and then I can expect this solution, and then that's just going to be, be done with it. And then this is like a good enough solution for me, because, this does solve the problem, and it didn't use any tricks, right? It just, used the subset knowledge of the account and stuff, which, is kind of common. Yeah. So yeah, I agree with these discussions wholeheartedly. And I don't think, if some interviewer give you this question and expecting to know this, this answer, I would just, get the hell out of that company. I'm not sure that interviewer is even qualified to interview these people. That person is just, trying to ruin your interview experience, basically. Yeah, so that's that. But for here, yeah, I'm not sure if there is an optimal solution, basically. Okay, let's just go to the hints. What is it saying? Use nested loops, run through all possible. Yeah, that's what I did. And then for each to iterate through the values, get maximum. Yeah, that's what I did. Yeah, that's what I did. I didn't understand the description. Never heard of max pooling, machine learning, the kernel size. This is my actual problem is asking simulate. Okay, doesn't look like it's attached to me. Gives a middle level complexity. I mean, never can be saved. Understand max pooling strides without padding. Exciting window. Maybe you're just competition. I'm not sure what that means. Maybe there's like a machine learning algorithm or something. This task is almost similar to the how maximum pooling layer works in neural networks. Okay, maybe there's kind of like a machine learning algorithm that uses this. Okay, I think there is no maximum. No, not maximum. Sorry, there is no optimal solution here. It's just this is it. Okay, I'm fine with that. Okay. Yeah, that's all for today's video, and then see you on the next part. Then, bye bye.